Hello everyone, today I'll be explaining how to integrate such equations by using trigonometric substitution. The things that you will be seeing would be a right angle triangle at the end of the solutions and this symbol called theta, and a lot of it. So first we have to identify what do we want to substitute our x with, and how do we know this is by following this table given here. And as you can see, I have already highlighted this part with red, and it actually shows you that 25 here is your a squared minus your x squared. Yes, here. So we'll just let x equal to a sine theta. So now that you let your x equal to a sine theta, and you know that your a is actually, your a squared is 25, so you can find your a, which is square root of 25, which is equal to 5. So now that you get your x equal to 5 sine theta, and when you differentiate x in terms of theta, you get 5 cos theta. And shifting the d theta over, you can actually get your dx, which you substitute inside the equation, and you get this. So as you can see, the whole purpose of this part is to get everything in terms of theta. And now you can substitute your x equal to 5 sine theta into your axis, x, and your dx equal to 5 cos theta d theta into your dx. And from there you can see equation that looks like this. So from here we actually square the 5 sine theta into 25 sine squared theta. Moving on, now we actually find out that we have a common factor in the denominator part, which is 25. So you can actually just take out the 25 from both equations, and you end up with 25 times 1 minus sine squared theta. So from this 1 minus sine squared theta, we can actually just turn it into cos squared theta by using Pythagorean identities, which is this equation. So it's basically sine squared theta plus cos squared theta equal to 1, and just shift the sine squared theta over the other side, and you end up with cos squared theta equal to 1 minus sine squared theta, which is what's shown here. And now that we have cos squared theta, we can finally square root the entire denominator, and square root 25 would be 5, and square root cos squared would be cos theta. And seeing that we have a 5 cos theta over 5 cos theta, you can actually just cancel them both. And after cutting both of them, you end up with only the integral of 25 sine squared theta d theta. And from here, you can't actually just integrate the sine squared theta. Well, you can't. You just don't try. Okay. We actually have to use double angle rule, where we need to substitute sine squared theta into something else. So the equation we used was cos 2 theta equal to 1 minus 2 sine squared theta, and changing everything over there, over here, and you end up with sine squared theta equal to half of 1 minus cos 2 theta. So substituting this whole thing with sine squared over here, you get 25 times basically this whole part. So now comes the more simpler part. After substituting everything, we now end up with some numbers outside, which we can bring out. Just bring them out, and then we can integrate the inner part, which is 1 minus cos 2 theta with respect to theta. And by integrating that, you will actually end up with theta minus sine 2 theta over 2, because when you integrate 1 you get theta, and you integrate cos 2 theta you get sine 2 theta over the differentiation of 2 theta. And bringing everything inside, you will also get 25 over 2 theta time minus 25 sine 2 theta over 4, since it's 2 times 2. And don't forget your c, which is constant. Now that we have finally integrated the main equation, we end up with this. So now we need to actually bring everything back in terms of x. So we have a double angle here, which is quite a problem. So we'll have to sub in the equation sine 2 theta equal to 2 sine theta cos theta. This is a double angle formula. So bringing 2 sine theta cos theta into this equation, you actually get 25 sine theta cos theta over 2, since it's 2 over 4. And now that we have gotten rid of the double angle, we can finally find our way back to getting everything in terms of x. So how do we get it is going back to x equal to 5 sine theta, we can actually let sine theta equal to x over 5, and where your theta would be your inverse sine x over 5, which is your theta here, and also here, and your sine theta would be your x over 5, which is here, and your cos theta. You see, remember I said something about triangles. This is a right angle triangle. This is your theta. So your sine theta is your x over 5, which is your opposite over your hypotenuse. While cos theta would actually be your adjacent over your hypotenuse. But we don't have adjacent actually. So your adjacent, using Pythagoras rules, we actually use your adjacent as your hypotenuse square minus your x square, which is your opposite square. And from there we just put it cos theta equals to adjacent, which is this over your hypotenuse 5. So after all that substitution, we can finally cancel off whatever factors that we have in common. So 25 can be cancelled with 5 times 5 on here, and we'll just end up with this. And always don't forget your c, since it is an indefinite integration. So that will be all. Thank you.